All right, welcome everyone. I'm going to give everyone a few moments to join, and then we'll do a quick intro about Acelab, show you guys how to get in touch with today's presenters and some of the tools and resources that we offer, and then we'll get started with today's CEU event.
All right. Cool.
Cool.
Thanks, Bo.
Yep, looks like a good amount of folks are joining in. So Helen, feel free to take it away whenever you're ready.
Sounds good. Hey, everybody. My name is Helen, and I'm the Director of Architect Experience here at Acelab. My job here is basically to show you all about the features, and then one of my favorite parts is meeting with folks and hearing about their firms and kind of coming up with a plan of action based on, how you work and how you work with your clients and your contractors on the best ways to use Acelab. So today I'm going to quickly talk about a few things. I have this all set up, but I actually want one other window. I'm going to talk first and foremost about what to expect after this webinar. So after this webinar, you will see a poll come through. Feel free to complete that and let Peter here know what you're looking for. So once you've done that, we will send we'll connect you to whether you're looking for, technical information, product information, etc. Our team will create that message on your behalf based on what you do in the poll. Then you'll get a conversation started. It will show on your screen here, like you'll have a little alert. You'll also get an email as well about the message. You can respond directly from the email. A couple other things that I like to point out here. If you want to get in touch with Peter and his team, you can always type in a brand name here at the top, make sure brand selected, find that brand. This will take you to their brand page. And here you can reach out by hitting request information, but also going on down to, you can see all of their products and learn a little bit more about them. One of my favorite things to do is to save these different products into your projects. And once you've done that, what you're going to get is something like this. So this is called a comparison. I'm showing cladding, not the kind of Dörken products there that we have, but this will take all the products that you've saved into a project, and we make a really nice apples to apples comparison for you. Let me try and refresh this here. Been having some IT issues on my side, so hopefully not on yours. Let's see. All right, yes. So here, scrolling down, you're going to see highlights. If specs, CAD, or BIM files are publicly available, you'll see them here as well. You'll see a lot of information. This information is going to vary depending on what building category you are looking at. So Windows is going to show some different information, and then we make these graphs as well. So this exists currently. I'm going to share a new feature that's coming out in September, but also if you'd like to meet with me, we can also talk about early access for you. And that is this. This is a schedules function. So all those products that we just saw there on that comparison page, we now also have this ability here. Lots of options for you. One of these, for example, is that I could create this as a view. I could then share this with my client. It's a link. And then I could say, hey, I just want my client to be able to edit the status field. And so it's a nice way for you in real time to be able to kind of get approvals and information with your client. Also a great thing to share with your contractor. You can also export this as a CSV. So you can also create a view that maybe matches what you need in your documentation drawing sets. And you can just export this out and drop it into your files there. One other nice thing about this is if we were to build out a firm library, or even if not, if maybe we say, hey, we really liked these two products, let's use them on the next project, you can select them here and you can copy and paste them, over into your next project. So lots of fun options, lots of fun stuff coming up. And I'd love to, again, meet with you. And then what I really like to do is kind of come up with a custom plan of action, based again on how your firm is, on your firm library and structure, et cetera. So I will pass it back to Peter. And yeah, thank you so much.
Awesome. Thanks, Helen. We'll launch a quick poll if you're interested in signing up for a demo through the poll. You can respond to that, and Helen's meeting link will be in the chat. So if you want to just book one directly, you can do that there. A few quick housekeeping items from me before we hand it over to Peter for the CEU. Please ask questions throughout today's webinar. I'll be keeping an eye on those questions so we can get to them live if we have enough time. And if we don't get to your question live, we'll have a record of it so we can follow up with you after today's event. Other than that, we did ask for AIA numbers upon registration. We'll also send over a form in the chat briefly to collect them in case you're worried you didn't include your AIA number or if you need to specifically request a certificate. So stay tuned for that coming through the chat as well. All right, other than that, just want to thank everyone so much for joining today. And Peter, whenever you're ready, feel free to go ahead and get started.
Oh, thank you so much, Bo. Folks, I'm very happy to be here today. I appreciate you taking the time out of your busy day, particularly in midsummer when most of us would rather be on vacation. So thank you for taking the time out today to come and learn something. Today, we're going to be talking about drainage mats and real life performance. This is an AIA approved uh, uh, presentation, so you will get an hour, or sorry, one credit out of this. So this presentation was put together in conjunction with RDH Building Science. So we've had them put it together, and we've worked with them to try to deliver the best information we can on drain boards. So what will we be doing today? One of the biggest design oversights made in below grade water management is selecting the most appropriate drainage for a specific project. Many factors contribute to this oversight, including interpretation of test results, which we will cover, cost considerations, which we will cover, and real-life performance of these applied products, which we will also cover. The presentation is designed for architects, engineers, and other industry professionals, and it is an introductory level technical content that will call upon typical applications where drainage composites and materials are often used. You'll see some details of ASTM tests, and we'll also talk about the importance of, or unimportance, as the case may be, of compressive strength testing. Additionally, we will discuss the importance of effective drainage and long-lasting drainage composite systems and strategies, how they're relevant, and what the appropriateness of the drainage mat's compressive strength is, while focusing on what you really care about, which is the actual performance or real life application of these products, and the concept that you can have a high quality product without breaking the bank. Well, being AIA, we do have some learning objectives. By the end of this presentation, you ought to be able to identify the fundamental components of various drain composite materials and their function and purpose. You should be able to describe the details of ASTM D4716 flow rate test and ASTM D6364 compressive strength versus real life performance expectations. You ought to be able to discuss the considerations when selecting appropriate drainage mats for real life applications, as well as list the benefits for selecting an appropriate drainage mat in relation to the cost and the investment of the project. So come on, move down. There we go. So why are we here? Well, we're here to talk about drain boards as a part of an effective water management system for your building. So we shall open with the science of drainage. Water management. Why do we manage water at all? Well, water, beyond being the single most destructive thing for our buildings, it can have a more specific impact on things like the structural integrity, i.e. the things holding the building together, indoor air quality, i.e. what the occupants have to experience when breathing, occupant comfort. In other words, they don't want to feel the dampness, the mold, the discomfort of just being there. We all want a great occupant experience. We want the building to function properly. We want the things in it to be able to function properly. And we want our material to be durable so that it does this a long time. Once we deal with a basement, we don't want to have to deal with it again. What is the need for water management? Well, this is a precipitation map of North America. So you can see the better part of it gets significant and substantial rainfall. And particularly in the areas where we like to build basements and below grade, much of it still gets significant annual rainfall. So there are some basics to groundwater and stormwater management. there are the 4 Ds of water control. Now, these may be familiar to you because we also talk about the 4 Ds of water control when we look at above grade wall systems. We look at deflection, the simple mechanical function of directing water away. Drainage, so that's the function of taking collected water and allowing it to flow somewhere else. Drying, once something gets wet, we would like it to get dry. That can be done, for example, through ventilation. And durable. As I said earlier, we need our material to last. So 3 of these are particularly relevant to below grade water management. And that would be deflection, drainage, and durability. So where does water come from? Well, water intrusion requires 3 main things in order to get into your building. One is an opening, and it doesn't have to be a very big opening, as you can see by the drawing. You need water. Prima facie, that seems pretty logical. No water, no leaks. But most importantly, you need some force to drive it in there. And we generally call that force hydrostatic pressure. What's really important is you need all 3 of these to occur at the same location for a water leak or intrusion to occur. If you eliminate any one of these factors, you can successfully stop water from entering your building. No opening, no water leaks. No water, no water leaks. No hydrostatic pressure, no water leaks. So when we refer to water, by the way, we're specifically meaning precipitation like rain, snow melt, water runoff from other surfaces, as well as things like your roof and that sort of thing, as well as the irrigation surrounding the building. So let's look at each of these important strategies separately. At the exterior of the damp proofing or waterproofing on the concrete, or exterior insulation if you happen to be putting that in, a robust drainage material should be installed to help shed and direct any intercepted water towards the perimeter drain system. This typically consists of a drain mat as well as perimeter drainage around the footing. I'd like to point out that perimeter drainage is very important when we're dealing with drain boards, because once we guide that water to a place, we'd also like to be able to carry it away. So that is a critical part of a well-functioning water management system. So what are some of the challenges down there? Well, it's important to have a reliable drainage system in place to prevent water damage in any construction project. If the waterproofing system isn't done correctly, hydrostatic pressure can build up, and even the smallest foundation crack can become an entry point because it has our 3 features: water, pressure, and a hole. The first step in building a new building is digging a hole in the ground. Sounds pretty straightforward, but in broad strokes, builders dig a foundation, pour concrete, and fill the hole back in. The problem, and it's a pretty universal one, occurs because the soil around the new foundation is less compacted than the untouched soil around it. As water moves through the ground, it will look for the path of least resistance. Water does that pretty much anywhere. It looks for the path of least resistance. Namely, it will move through the looser soil. Much easier to drain through the loose soil than the compact stuff before it ultimately starts accumulating against your building's foundation. This is what we call hydrostatic pressure. So that means that your foundation has hydrostatic pressure on it, as well as the effect of earth pressure. You can simply define hydrostatic pressure as resting water exerting a load on an adjacent solid entity like a concrete foundation wall. The consequences of hydrostatic pressure on unprotected below grade walls can lead to structural damage, mold, and pests such as carpenter ants or termites. All of that can happen. So it's important to understand that hydrostatic pressure exists in all soil types. All soils trap at least some moisture. So even if you're building in a relatively dry place, homeowners and building owners should still make sure their home is able to withstand hydrostatic pressure. Another part of that was drainage. So one of the ways that you can relieve the pressure is by reducing the amount of water against the foundation. The appropriate drainage mat can be a solution. Drainage mats are a great way to achieve drainage, particularly in below grade and roofing applications where some compression, strength, and resistance to soil intrusion is required. Because while we can manage the water with a drain board, you can't necessarily manage the soil load with the drain board. Durability. Again, this is something that's very important. It needs to last in order for it to be of any use at all. Anything that isn't durable is not sustainable. So even with deflection and draining, drying in wet below grade and roof applications is not particularly practical, which is why we rely on durable materials. Membranes and products exterior of the membranes should not absorb water or have their function damaged by water. The material behind the membranes benefit from durability, which is a good reason for a concrete foundation wall rather than, say, wood or other alternatives. Additionally, selecting a quality of material that will maintain flow rate performance both in the initial backfill and with the sustained force over time, but will maintain the flow rate during the entire service life is essential, even with a concrete foundation. A little more about durability. Well, even with deflection and draining, drying in wet below grade roof applications is not particularly practical, which is again why we rely on durable materials. Oh, I'm repeating myself. I apologize. But maintaining the drainage gap is critical. When that drainage gap is the space that actually allows the water to flow. If we don't maintain that drainage gap, you will not get the flow rate. Several things can have an impact on that, and that's pressure from the backfill, as well as the long-term deflection of the filter fabric due to soil pressure over time. So let's look a little more at drainage mats. As we said, this is an excellent solution to water management. While there's a lot of options in drainage mats, and it may seem simple, it's important to realize that they are not all created equal. But first, let's look at some common terms. When talking about drainage mats, you will hear several terms. You will hear drain boards. You will hear dimple mats. You will hear a composite drain. You may even hear a composite geotextile drain board. You may hear a dimple board. But in essence, all of these things are a board designed to provide a drainage in the system. They're all drainage solutions that collect and divert water. All right. So where are drainage mats functional? Well, on just about every side of your foundation. You can put it on the exterior wall, you can put it under slab, you can put it on the floor. So to the exterior, we use the term vertical positive side application. Call it positive side because you can get and work on the exterior side. Then there's a blind side application, so called because you cannot get to the outside to apply your products. So in essence, we put everything on in reverse order to what we would do on the vertical positive side. As well, there's horizontal applications. Let's look a little more at the vertical positive side. So this is applied after the wall has been poured and the forms have been removed because we require access to the exterior. Highly effective drain boards that control the flow of water below grade in vertical applications, taking it out and away from the building foundation, is very important for the water management. Having a high flow rate capacity ensures effective drainage and helps prevent the buildup of hydrostatic pressure. Also important, we do not want the geotextile to rot, and at the same time, we do not want it to allow dirt particles through to clog. Blindside application. So blindside you will typically find in areas with soil retention systems. In this case, we're showing lagging with piles, but there's other forms of soil retentions such as shotcrete walls or sheet metal can be used. There's a number of different ways to hold back the soil. But what that means is we're usually working with a zero lot line, often in an urban location. So you can't dig out farther than your site. So everything must be done within the site. Therefore, we do the blindside application. As I said earlier, essentially, we're going to build our water management system backwards relative to the positive side. So we're going to put up the drain board first, which also acts as a great way to smooth out that rough lagging. Then you'll put up your waterproofing. Then you'll pour your concrete. That is a blindside wall. If you're in Europe, that also might be called a Berlin wall. Horizontal. Well, horizontal probably can take some of the larger loads. But what's really important here is that we have a highly effective drain board that controls the flow of water in a horizontal application. A high flow capacity ensures effective drainage and maintains that drainage space and won't rot, won't clog with effective geotextile fabric. The drain board needs to be designed to last with decent compressive strength, high impact chemical resistance, and resistance to environmental stress cracking. There's a bunch of different things that drain boards on the market are made from. Drainage mats, a drainage board or a drainage mat helps water flow away from the foundation, but without it, water can stay trapped against the concrete, hence that hydrostatic pressure we spoke of earlier. Drainage mats can come with a dimple design that lets water accumulate and flow away by the creation of an air gap. As water flows, it picks up small particles of dirt and silt. What's important is that we don't want that dirt and silt to flow into our dimples or our drainage space at all, because that will inhibit and fill, or that will inhibit flow and fill the actual space that we want water to be flowing through. A drainage mat's membrane protects the mat from sediment clogging. So here's a whole bunch of different shapes, as you can see on the screen, used to create the dimple design along with a geofabric. So let's talk a little more about the filter fabric, which is a really important part of a drain board because it really helps create that drainage space. As I said earlier, as water flows, it picks up small particles of silt and soil. The filter fabric helps filter those pieces of silt, those little pieces of silt and particles of soil out, which helps prevent that sediment from clogging the dimples, as well as helping to maintain the drainage gap during the backfill, certainly from impact, for example, and for long-term soil pressure during service. Consider quality. These fabrics can be attached by either being heat welded, glued or bonded, or even loose laid. If they're not fixed on every dimple, that fabric can stretch and begin under load, impinging on the space between the dimples, thereby becoming less effective. It has been shown that those that are attached at every dimple will have better performance at resisting soil pressure. So now we can talk about describing performance. Most every manufacturer will put out a technical data sheet that will consist of the type of material, as well as the properties of that material and testing results. We shall get into the testing later, but it's worth noting that not every manufacturer chooses the same tests, and not every manufacturer publishes the same information or the same amount of information. But to make sure that we're choosing the right drainage mat product, let's look a little more at the key performance metrics. One of the big ones that we talk about is flow rate. This is pretty logical, given one of the primary reasons we're putting the drain board in is to have water flow through it. What you're seeing here is a drawing of the typical flow rate testing apparatus. There's a water reservoir to provide the water. There's the confining pressure to go over the specimen to provide the load. And then there is the water collection and measurement on the far right. This method covers the procedure for determining the flow rate per unit width with the manufactured plane of geosynthetics under varying normal compressive stresses and a constant head. This test is intended primarily as an index test, but can also be used as a performance test when the hydraulic gradients in the specimens contact the surface and specimen contact surfaces that are selected by the user to model anticipated field conditions. In other words, we can make this a lab test, or it can be made to represent your actual site conditions so that you could see how it actually might perform in situ on your project. But there's a bunch of considerations with this test, and there's choices that you can make in the performance. There are several different test conditions. One is slope. If you see somebody publishing a measured on a 0.1 slope, then they have measured it horizontally. If they have measured it at a 1.0, then they have measured it vertically. There's also varying compressive pressures that one can put on. You can put in different substrates. You can put in different loading materials. This probably won't come as much of a surprise to anybody, but manufacturers will typically test with the most favorable conditions for their product performance, which can vary an awful lot from real life conditions and performance. So consider this text with context. You wouldn't want to select a mat strictly from performance testing, but evaluate it more holistically. In other words, cost, material quality, fabric installation, project performance requirements, conditions. Among other things, for example, you can vary on here, will be the compressive strengths. Sorry, I want to be clear, these are all allowed within the ASTM. So you can vary compressive strength, you can vary the hydrostatic pressure, you can vary the hydraulic gradient, you can vary the load, you can even vary the water temperature. Warmer water will flow faster than colder water. So this is one of the challenges that designers face when selecting drain board, that the water flow rates claimed on a technical data sheet are often not representative of the actual in-service drainage performance of the products. This is because during service, the soil pressure against the drain board deflects the geotextile into the drainage space created by the dimples, thereby reducing the in-plane flow rate. Now, there is some subjectivity to this. Third-party testing of drain board products is available in the market using this ASTM D4716M-22, to be specific, test. It would typically, so you can use one rigid plate and one rigid plate. That will put a load on the dimples, but not on the geotextile. That's not very representative of typical installation conditions. Most of us do not put a drain board on a concrete wall and then put something rigid like perhaps another concrete wall against it. Not that that's unheard of, it's just not very common. So an example of what can be more reflective of in situ performance is if you use that rigid plate, which is the one on the bottom, and then in that load platen, you would add a sand plate so that would better reflect the in situ conditions. One study found that with 3,759 pounds per foot squared and a 1.0 hydraulic gradient, in other words, vertical, we found a variation between 20 and 78% reduction in water flow rates amongst other drain boards in the market. One drain board claimed a flow rate of about 21 gallons per minute per foot, but only achieved 5 gallons per minute per foot when tested, a 78% reduction in flow rate when in service. Another common test is ASTM D6364. This is the procedure for determining short-term compression behavior of geosynthetics. Bring this up because sometimes high compressive strength are used as the sole selling point. So the compressive behavior in this test for geosynthetics is intended to be an index test as well. It's anticipated that the results of the compression behavior test will be used to evaluate the product. The results of the analysis may also be used to compare the relative compressive yield points of materials that exhibit a detectable compressive yield point. This test will be used for quality control testing to evaluate uniformity and consistency within a lot or between production lots where sample geometry factors, for example, thickness or materials, may have changed. As you can see on this particular picture of it, what you're really testing here is the compressive strength of the dimples, not the effect of the compressive strength under soil load on the performance. Just so you can see, those are two different things. So this is a little test machine that we put together that basically is a version of the drainage test we saw earlier, ASTM D4716. And as this spins around, as it will eventually, we put it under load. Let's get to the next one. We put it under load and then did some testing. So we have two different products. The sample size is 6 inches by 12 inches. So this reading you see on the measurement of the load is for a half square foot. So to get the loading for a square foot, you simply double that. So that is approximately 3,800 pounds per square foot of load. You can see the one on the left has had some significant flow reduction. The one on the right is still flowing very, very well. So how does this have an impact on your design decisions? Well, we're all familiar with the technical data sheets of products and how the ASTMs are used to populate this sheet. But how does this affect your design decisions? Well, these metrics are all based on testing. It's important to understand what testing does and does not tell us about real-world performance. We have some design challenges based on testing. One of the challenges designers faced when selecting drain boards is that the water flow rates claimed on technical data sheets are not are often not representatives of the actual in-service drainage performance of these products. This is because during service, the soil pressure against the drain board deflects the geotextile into the drainage space created by the dimples, thereby reducing the in-plane flow rates. Additionally, for below grade, soil challenges can have an impact on design. There are several specific challenging soil conditions which elevate both on and off-site risks associated with groundwater and stormwater management. Sensitive or collapsible soils can behave unpredictably when water is introduced, and this can negatively affect bearing conditions for proximate buildings. Swelling and shrinking clay are soils that can be subjected to significant volumetric change associated with the amount of water present in the soil. Organic soils, including peat, are generally weak and can deform excessively when subject to new loads. Come on, there. Oh, sorry about that. Where has my share gone? I apologize. I shall fix that quickly. There we go. All right, so there we go. Get to the correct page again, subjectivity and testing. So drainage testing impact on the building code. Code is divided into two parts, prescribed and engineering design solution. The code refers to performance expectations as it pertains to drainage and deflection, as well as damp proofing and waterproofing. What it doesn't do is give specific product or prescriptive product requirements, such as a drainage mat. It won't say that you must install a drainage mat. It will say that you must have drainage. So let's talk about selecting an appropriate product. When you compare the performance available from the product with the project requirements, largely in the form of loads applied to the system, keep in mind that these might be structural loads, but can also be environmental loads, such as anticipated water flow rates. Some of the things to consider when you're selecting material. Obviously, the application. Where are you putting it? What kind of properties and qualities do you require? In other words, what do you need to do? What's most important to you? Obviously, your budget. As well, we want to consider the long-term benefits. As an example, I'm fond of saying anything that's not durable is not sustainable. So let's look at some of these qualities. So let's look at the properties and qualities. Consider from what the drainage core is made. Does it include a fully bonded geotextile filter fabric to allow water to pass along the drainage core while limiting the passage of soil particles to ensure long-term drainage capacity and performance? Is the product rot-proof? Oops. How malleable is it? Is it easy to handle? Is it easy to cut? Will it bend around corners? Does it provide the appropriate compressive strength for your application? Designers will commonly select drain boards assuming 100% of the claimed flow rate on the technical data sheets, but under real world conditions achieve only between 22 and 80% of the claimed flow rate. This gap between the assumed and the inflow service rate can result in undersized drainage systems that are already less than increasingly extreme precipitation events require. I'm sure we can all relate rather quickly to extreme precipitation events, as we've had several in the last month all over North America. I live just outside of Toronto, and we had one a mere 2 weeks ago. Is this product designed with the ease of installation in mind? Because your team has to install it. So drainage mat applications. The required compressive strength of drain board depends on its application and the type of assembly used. Two key examples that often get overlooked are the impact of soil weights on the drainage capacity and the required structural capacity, which is often much less than you might think. So let's do a little quick case study. The client required a drainage mat tested at 10,000 PSF for an inverted roof project. However, structurally, the roof wasn't designed for 10,000 PSF. So why do you need 10,000 PSF in a drainage mat? 8 to 10,000 PSF is a common request, but are you really going to see this pressure in real world applications very often? Were we in a room, I would invite you all to share stories on this. In fact, if you want, you can even drop them in the chat. That would be wonderful. So let's look at some of the real world pressures that you will encounter in various applications. So when considering whether the drain board is suitable for applications such as an underground wall, tunnel, a caisson, pile and lagging wall drainage, retaining walls, bridge abutments, or as a relief layer for hydrostatic pressure on any substructure, you should consider whether it can also function as a protection board. Most waterproofing does require a protection board of some sort. As previously mentioned, the required compressive strength of drain board depends on the application and the type of assembly in which it is used. So as you can see, a typical below grade wall will encounter around 3,500 pounds per square foot. If you think back to the demo that we showed you that was running at 3,800, you can see that even at that pressure, it can have significant impact on the flow rates of the drain board put in. A typical vehicular access roof, you're running around 2,250, give or take. Green roofs, really, really low compared to other applications. Even if you have an intensive roof up there, it's not going to be greater than around 500 PSF. Then we have pedestrian roof access. So typically with people moving around on it and along with the other components, you're generally going to require around 3,600 PSF. So this chart is drawn from ASTM 6364, the compression test that we looked at a little earlier. The compression behavior test for geosynthetics is intended to be an index test, as we said earlier. It's anticipated the results from the compression behavior test will be used to evaluate the product itself. The results of the analyses may also be used to compare the relative compression yield points of materials that exhibit detectable compressive yield point. It is anticipated this test will be used for the quality control testing to evaluate uniformity and consistency with a lot or between lots where samples and the geometry matter. As discussed earlier, what are the true requirements based on the application? Based on the pounds per square foot calculations discussed earlier in the previous slide, do you really need to pay more for an 18,000 pound product? Oh, sorry. So you can see that at 10,000, most of the applications are covered at under 10,000 PSF. Ease of installation. Probably the biggest guarantee to you getting what you want on your job site is how easy it is for your contractor to put in. You can look for installation aids. It can be made out of a product that's easier to cut. Let's say polyethylene as opposed to polystyrene. Here are some other key features. The product may have a self-adhering edge, meaning that when you overlap it, you can stick it together. Very useful in horizontal applications as it reduces wind uplift and reduces the amount of ballast required. Wider and lighter rolls. Most products come in a 6-foot wide roll, but some are wider. Larger rolls mean you require fewer for a project, you have fewer laps, and you can cover the area much more quickly. As well, lighter rolls are very simply easier to handle. You also want to consider the workability. That's not just how easy it is to cut and bend, but you also want it to be able to relax when unrolled on a flat surface, particularly because you don't want to spend your time running around putting that curl back down. Budget. None of us are concerned about budget, are we? Our clients are limitless piles of money. That would be nice. But budget is affected by both the product cost as well as it is by how friendly it is for your installer to put in. The easier the installation, the less the labor, and ideally the cheaper it is for you and your client. You also want to look at some long-term benefits. Reduction in water impact, or sorry, reduction in water intrusion can have an impact, as we said right at the outset, and I'm going to repeat it here: structural integrity, IAQ, occupant comfort, and their ability to actually live in the building. The overall building use, a good example of that is if you have your computer server in the basement and you have a leaky foundation, that is a poor combination. So you also want to be able to put it in, remove it, get out and dispose of it fairly quickly. So no product installation can be perfect. Water might still get in, but by having good drainage, you can minimize the amount of potential water that can get in. This will take most of the water away from your actual waterproofing. And it will mean that your waterproofing has less water to manage itself. But this is also going to change in the future. Buildings, and especially drainage systems, need to be future-proof and resilient to the effects of climate change. This climate change resilience supports the need for higher flow rates, long-term drainage capacity, and reliable inflow or in-plane water flow rates. For example, the southern US is hotter and wetter than ever before. Temperatures in Houston, Texas have increased between 0.6 and 1 degree Fahrenheit, and annual rainfall increased by greater than 2 inches compared to the previous 30-year average. I think if our memories aren't too bad, we can remember Houston just had another significant rain event. Designers can select drain boards assuming 100% of the claimed flow rate on the technical data sheet. But under real world conditions, only achieve between 22 and 80% of the claimed flow rates. The gap between the assumed and the inflow service rate can result in undersized drainage systems that are already less than increasingly extreme precipitation events require. This may result in damage to below-grade structures or roofs, more unexpected costs, inconvenience, and general pain in the butt to try to repair. So consider some of the projects where you've had basement leaks. Consider a previous project and the key performance differentiators of the product that you used, either good or bad, such as ease of application, resistance to soil intrusion, and just how budget friendly was it in order for you to get the performance that you required. Well, folks, we're into the recap point. Let's look at some of the key points that we've made. Not all drain mats are created equal. Installation approaches have an impact on the best product for the application. Focus on decision-making properties such as quality and installation. Consider performance differences between lab testing and real life. Folks, it's been a pleasure to take you through this little presentation. I am happy to answer some questions.
All right, awesome. Thank you so much, Peter. We definitely have a few questions, so we will get started with those. And reminder for anyone who hasn't entered a question, if you have one now, it's a great time to enter it into the Q&A. All right, so if it sounds good, I'll just kind of start at the top and we can take it from there. All right, first off, how much weight could the drainage mat hold on a horizontal application before crushing or making the system not work properly?
So that is a good question. It's first of all going to depend on the drain board you have chosen. So you saw earlier that we had some examples of uh, um, typical forces that one will experience in various applications. So drain boards will typically crush if you definitely exceed the rating. You can also crush them if you do that with exceed the rating with a point load as well. But typically, uh, uh, drain boards that are made out of polyethylene or polystyrene, the ones that we're used to, um, or sorry, polypropylene and polystyrene, the ones that we're used to, typically we see those ratings not because that's what's required, but because that's what you get when you form it at that thickness in that shape. So the reason we have a a uh, a 16,000 pound board isn't because there's a lot of 16,000 pound per square foot jobs, as you see as you saw earlier. Uh, Many pressures rarely exceed 10,000, but it's because when you form it in that shape, in that size, that's the compressive strength you get. But I think really to wind myself back to the beginning of your question, they will definitely crush if you exceed their load rating.
All right, awesome. Okay, next up, do you recommend installing a drainage mat on the exterior side of foundation walls of a load-bearing brick masonry building built in the early 1900s? Does it depend on the pervious or impervious exterior surface that meets the foundation of the foundation wall, soil and landscaping versus a concrete sidewalk, for example?
So I'm not 100% sure why the age of the building is really relevant here. Um, but yes, I recommend putting a drain board on the perimeter. First of all, it makes a great protection board for your waterproofing to resist damage from backfill as well as other construction going around. But what you described as the soil around it, so the perviousness of your landscaping or hardscaping, whatever you've done around it, will have a significant effect on the amount of water your foundation will experience. Another part of that isn't just the material you make, it's also the grading. So you should have a minimum 2% grade away from your foundation to carry surface water away before it starts percolating through whatever your pervious landscape or hardscape may be.
Mhm. All right, great. Looks like we've got a few folks who are just asking if you would be able to provide a copy of the presentation to them. Is that something you're able to share with folks?
I can do that.
Okay, great. So yeah, we've got a record of those requests. All right. Who is responsible to specify the mat? Civil engineer or architect?
That's a really good question. So it's going to depend on the way that you um, operate your particular project and what kind of project it is. If it's a typical building on which an architect may work, then generally the architect will specify it along with the waterproofing. On a broad statement, whoever specs the waterproofing should also spec the drain board. Um, but if it's a larger civil project, let's say we're putting up a roadway and we want to put drain board behind the embankment, that'll be our civil engineer. It's even possible for your geotextile engineer to get in the game as well. Again, depending on the kind of project that you're building.
Great, awesome. Okay, hydrophobic polyurethane grout. Are you familiar with it? If so, what is your experience or opinion on its effectiveness in stopping water leaks?
So I'm definitely not a grout expert at all, but typically grouts are designed to fill holes. And if you're going to fill a hole, that definitely takes away one of the three critical things we need in order to have a leak. So you're going to fill the hole. Grouts, of course, got to be installed correctly. You got to have the surface really wet when you put it in. That way it doesn't pull away and just create more holes. But I wouldn't consider that a replacement for waterproofing or a drain board because we want to manage that water before it gets to the grout.
All right. Would you recommend specifying drainage mats under cast-in-place planters and partition walls above the structural deck and waterproofing?
If you can, sure, because the having a continuous plane of flow is always better than having an interrupted plane. But if I was in your office and we were talking about this, my first question would be, well, what's underneath it? If this is an overburden over a space, then we're much more concerned.
All right. Are there any part of the Dörken drainage boards that are recyclable? What is the best way to dispose excess boards after installations?
So the question is, what do you do with your scrap? So the the boards that we make one version out of polypropylene, and another version, the one that you saw through here labeled Terax, is made of polypropylene. They are fully recyclable. The ability to recycle them will depend on what your local garbage receiving service will take. Some will not take construction material, some will. But it's polyethylene, and you can recycle all types of polyethylene. When we manufacture in-house, we don't take our scrap and throw it in the bin. We regrind it and it goes back into our systems. So the short answer is absolutely it can be recycled. The question is, will they let you recycle it?
Mhm. All right, great. And then last one, do most drainage mat products come with pre-applied filter fabrics, or is it typically loosely laid over it post drainage mat installation?
Good question. So many come pre-applied. In my experience, many most do. One of the differences is the way in which are the fabrics chosen for one, and the way in which they're fixed for another. In the case of heat bonding to each and every dimple, then it gets a very firm fixation and it does a very good job of maintaining the drainage space. In the case of other ones, for example, some of that black fuzzy stuff that you're used to seeing, those are typically glued on, and they don't necessarily glue to every dimple, but those are the fabrics which under load can stretch. So it's really less about the way that it's fastened to the dimple, more about the fabric itself.
Mhm.
So a heat bonded geotextile itself doesn't stretch. When you put it under load, the fabric strands are fixed together. For the needle punch geotextiles, those fabrics are not fixed together, and they will stretch. An example would be, try pulling on your nylon shirt and then try pulling on your wool sweater. There's an example of the difference that the weaves will make.
All right, awesome. Well, looks like that has wrapped up all of our questions. So thank you so much for everyone who attended and for asking such great questions. And thank you, Peter, for a wonderful presentation. Before you hop off, there are quite a few helpful links in the chat, so be sure to grab any of those that you might need. There's a link for Helen's meeting link, the page for Dörken on Acelab, as well as where you can go check out some previous webinar recordings. And we'll be posting a recording of this webinar to that link as well in the next few days. So you can check back if you're interested in kind of taking a second look at this or sharing it with anyone else in your firm. All right, awesome. I think we should be all set then. Peter, thanks again so much. That was really great, very informative. We have a few thank yous in the Q&A as well, so looks like folks really learned a lot today. We appreciate it.
Folks, thanks again for coming out.
All right. Have a good one, everyone.